So when we think about a general curve, if I have a max or I have a min, what's true about the slope of that? Slope is 0 at a max or a min. If slope is 0 at a max or a min, what is slope again? In calculus, what's the slope? The derivative. So the derivative is 0 when we have a max or a min. So what do you think we're going to do today? We're looking for maxes and mins. And at a max or a min, the slope is 0, so the derivative is 0. So what do you think we're going to do? We're going to look at the first derivative test. Okay, so last class we looked at the extreme value theorem. When I chop the curve in a small piece, I have to have a max and a min. Now we're going to use our knowledge of derivatives and increasing, decreasing intervals to find where a function has a relative max or min. Unlike the extreme value theorem where it is the max or min for the problem, this is a relative, meaning we have a hill or a valley, right? It's a first derivative test. Why? We're going to use the first derivative. Okay. What is the slope when a function has a max or min? You just answered that. It's 0, or it could be undefined if we have some asymptotes, right? What is the slope when a function is increasing? So if you think about a function where I'm increasing, my slope is positive, and then where I'm decreasing, my slope is negative, right? So if you were given a curve, and it was increasing, and then that curve turned and it was decreasing, what could you deduce about what's in between the increasing to decreasing part? What are you going to call that point? That's a maximum, right? So if your slope is increasing, think about this now. If your slope is increasing, then it hits 0, then it's decreasing, then we know we have a maximum. We like working with the slope. Why do we like working with the slope? Because slope is the derivative, and derivative is down a power from the original. So our math is a little easier with the derivative, right? All right. To the left of a maximum, the function is increasing and the slope is positive. To the right of a maximum, the function is decreasing or the slope is negative. We have a maximum when our slopes go from positive to negative. Does that kind of make you think we might need a sign chart soon where we test? Yes, right? So start thinking about what you know. We use these in particle motion a lot, the sign chart with velocity, right? Acceleration. It's going to be like that, but all right. Let's look at the picture of a minimum. So what's happening now? We're decreasing, right? And we're negative. Then we hit this, then we're increasing or positive, correct? When we go from decreasing to increasing, we have a minimum. So go from decreasing with a negative to increasing with a positive slope. So when our slopes change from negative to positive, we have a minimum. And that makes sense if you just draw a minimum, right? You're decreasing, increasing. So let's put that together. And we have our first derivative test outlined. So when a function switches from increasing to decreasing, and I always like to draw a little picture, increasing to decreasing, slopes must go from positive to negative. The derivative must change from positive to negative. So we can make a little sign chart of the derivative, right, where there's a 0 and see if either side is positive or negative, and then we know. We don't have to do scary math. This is pretty easy. For a minimum, it's going to be switched, right? A minimum happens when, let's draw it. You go from decreasing to increasing. Slopes must go from negative to positive. So the derivative, the sign of the derivative must change from negative to positive. And how do we find out signs of a derivative? We make a little sign chart, right? We put the 0 in the middle and check either side to see if it's positive or negative, right? Okay, let's try. We're going to plunge right in. All right. Memorize the mathematical way of writing this. Graphical analysis, increasing, decreasing intervals. Critical numbers occur where the derivative equals 0. So we're still taking the derivative and setting it equal to 0, right? So we still have take derivative. 2, set derivative equal to 0. And notice here, this says f of x. So if the derivative is positive, the original equation f of x is what? Increasing. If the derivative is negative, then the original equation is decreasing. So we don't have to put in the scary ones. We work with the derivative. A relative max occurs when the derivative, make sure you're paying attention. This is derivative, this is not, this is derivative. So a max occurs when the derivative changes from positive to negative. A minimum occurs when the derivative changes from negative to positive. Okay, so let's go on in and see. Here is the parent. So we're going to first what? Take the derivative. I guess my third rule would be a sign chart to see where f prime of x is positive or negative, right? If it's positive, it's increasing. If it's negative, it's decreasing. It's kind of nice when they go the same way. So let's take the derivative. 3x squared minus 6x. We already like that better, don't we? And what do we say we should do once we take the derivative? Set it equal to 0. And I'm going to, of course, factor out while I go. What should I do once I take the derivative? Set the derivative equal to 0. What do I do next? What's the last thing? What's the last thing we do? A sign chart. This time we can have arrows on either side because x can be negative, right? We're not working with time. So I'll put 0 and 2. Now what am I going to do with that? We are going to plug numbers in to the derivative. Remember, this is a big distinction from last time. Last time we plugged back into the parent function, but this is called the first derivative test. So we're going to plug into the first derivative. So what's a number between 0 and 2? 1. And you don't have to write the 1 down. You're just thinking it. If you plug a 1 in to the derivative, is your answer positive or negative? You would get 3 minus 6. Is that positive or negative? It's negative. Now, if you take a number bigger than 2, 3, and you plug it in here, would you get a positive or negative outcome? Well, if I put a 3 in, 3 squared is 9, that's 27, that's positive. If I put a small number in, like -1, try -1, that's on the other side of 0. I'm going to get 3 minus -18, so that's going to be what? How did you know without doing the work that our sign chart was going to alternate on this one? Let's go back to pre-cal for a second. How could you tell that? None of our factors were squared, right? If we would have had x minus 2 and a squared there, then we'd know it bounced, right? If they're all single factors, we kind of know they're going to alternate. So what does a plus sign tell you in today's world with our first derivative test? That tells you increasing, negative tells you decreasing, positive tells you increasing. Now, really important, when I write the word increasing down, am I talking about the derivative or the original function? That's the original function. The original function is increasing, and I always like to say increasing to decreasing. This one is decreasing to increasing. So what do we have at 0? A maximum. And where do we have a minimum? At 2. And then we give the interval notation. Where is this thing increasing? Negative infinity to 0 and 2 to infinity. And we're going to put parentheses here because the 0 isn't increasing or decreasing, is it? It's increasing to the 0, then we have a 0. Then it turns around. Where is it decreasing? From 0 to 2. Not too bad for a test, right? This is called the first derivative test. Let's wrap up what we do. We take the given equation, we take its derivative, set the derivative equal to 0, put those zeros on a line chart, and we do test points to see whether it's positive or negative. Positive tells us that the mama equation is increasing. Negative tells us it's decreasing. Really important that we put that in our head and think about it, because we're going to add more tests to this as we go. So we really need this to sink in so we don't get confused on the next one, next block, right? All right, so let's look at this. Y'all walk me through. What are we going to do first? Take the derivative. So f prime of x equals 6x squared minus 6x minus 36. Not so bad, right? Now we're going to set it equal to 0. Now, what should we do when we see a 6, a 6, and a 36 to make life easier? Get rid of that 6, right? Can I divide both sides by 6 and not have to worry about that because it does not have a letter, right? So what is that going to be? You know, you could divide both sides by 6. So we have to factor that. What two numbers multiply to give us -6 that add up to -1? 3 and 2, negative minus 3 and plus 2. So x equals 3 and -2. What's the third step? 2 words, what's it called? Sign chart. What goes on the sign chart? Your zeros. And now what numbers are you going to test? You're going to pick a number between -2 and 3. What's between every negative and positive that's easy to plug in? 0. A number bigger than 3, 4. A number smaller than -2, -3. Now, where are we going to plug these points in to see if they're positive or negative? Into the derivative. That's a huge difference from yesterday where we plugged into the given. We plug in. So plug into derivative to test for positive or negative. So if I plug -3 into the derivative, -3 minus 3 is negative. -3 plus 2 is negative. And what's a negative times a negative? Positive. Plug 0 in. Then I get -3 times 2, which is a negative. And are you allowed to plug into the one you factored? Sure. And that's usually easier, right? Here we have 4. 4 minus 3 gives me a positive. 4 plus 2 is a positive. And what's a positive times a positive? Tell me another way you knew they were going to alternate. None of these factors have a square, right? So once you find one, what does a positive tell you? Increasing. What does a negative tell you? Decreasing. Positive, increasing. Now just sketch it so you don't have to remember. Increasing goes up, then decreasing goes down. Decreasing's going down, increasing's going up. So right here we have a max. Right here we have a min. So we have a max at x equals -2, a minimum at x equals 3. Increasing, if you want, you know, a visual, it's always good to color those in, right? And decreasing. So that helps you write your interval notation. It's increasing from -infinity to -2 and 3 to infinity. And it's decreasing -2 to 3. Any questions on the procedure so far? Any? Not bad, right? If we're going to do honors calculus, this isn't too bad. You know, of course, that if this is too easy, I have to give you some fun problems, right? Is everybody caught up with that? What are the rules? We just set find the derivative, set the derivative equal to 0, then make a sign chart. And we've been doing that for a while, right? Sign charts. Okay. What if we make the algebra a little more interesting? So let's take the derivative. Now we're going to set that equal to 0. See, I could pull out an x squared. So 1, 2, 3. Now I got a question before we start. Is there going to be a sign change at 0? Is there? I predict no. Why not? X is squared. So whatever we get here, we get here. Are we going to have a sign change at 3/4? Are we? Yes. Now, if I know that going in, how many numbers do I have to plug in? I only have to do 1, right? Because I know that it's going to alternate here, and I know it's going to be the same there. So what number in the whole world would be the easiest number for you to plug into this thing? 1. 1 would be over here. So if you plug 1 into the derivative, do you get a positive or a negative? You get 4 minus 3. What is that? Positive. So based on your knowledge, we're going to test it because I want you to test it. Based on your knowledge, will there be a sign change at 3/4? Yes, because this is not squared, so I know it's going to be negative. Now, based on your knowledge, is there going to be a sign change at 0? No, so it should still be negative. Do you totally believe me on that? You do, but let's test it. You can't trust me, right? So I could put a -1 in, and if you put -1 in, you're going to get a positive times a negative, and a positive times a negative is negative. If you put a half in right here, you're going to get a negative times a positive, which is a negative. So you were correct. So would you rather test all these points, or would you rather recognize whether or not change signs are going to alternate? I'd rather know that. Then I only have to find 1, right? True? True. So this is decreasing, decreasing, increasing. So this is decreasing to increasing. So what do we have at 3/4? What is that? A minimum. Maximum? None. Why do we not have any? Never changes from positive to negative. It's important for you to write the y's down. The more you can run the y through your head, the better you'll retain that information, right? You can graph it in the calculator if you don't believe me or you want to see it, right? Where is it increasing? 3/4 to infinity. Where is it decreasing? Now I got a question for you. I'm going to ask you two things. Is it decreasing from negative infinity to 0 and 0 to 3/4? Or is it increasing negative infinity to 3/4? Yes, it's this. Why don't I have to write both of them out? When would I have to do this? If 0 was excluded, right? If it were in a bottom or a radical, then we would have to do that. 0 is not excluded from the parent or the derivative, so we don't have to break it up. If 0 were an asymptote, then I would have to do this one, right? Does that make sense? Everybody got that? Everybody's happy? Okay. Now we're going to repeat our procedure, but I'm going to review some calculus skills with you, like this nasty thing with an exponent. We need to practice a little algebra. So you already know what to do. We'll do a few with tricky algebra. So what do we do first? Yes, we take the derivative, people. Derivative 2 minus, what's 2/3 times 3? Just 2x. Now, what is 2/3 minus 1? Those pesky negative exponents. These can be dangerous for you to see if something's undefined, because you know what x can be, but you forget that it's in a denominator. So I highly recommend you do this. Since you're going to plug numbers in, it's much easier for you to see. Now, we need a common denominator. Let's think about this for a second. We need to know where derivatives are 0 or undefined. If you have a fraction, it's 0 when the top is 0. And if you have a fraction, it's undefined when the bottom is 0. Well, right now we can't plug anything into the top because we don't have one. We just have a constant. But if I get a common denominator, what will I have? I got to multiply that by the cube root of x. So I have 2 cube roots of x minus 2 over the cube root of x. Now, do you see the importance on why we wrote it that way? Why did we do that? Because we're looking for two things: where the derivative is 0 or undefined. A derivative is 0 when the top equals 0. A derivative is undefined, or a fraction, sorry. A fraction is 0 when the top is 0. A fraction is undefined when the bottom is 0. So we've got to have a variable in the top. So when you just glance at this, you would miss that, right? So what is x? What could you plug in here to make the top 0? 2 times what minus 2 is 0? 1, right? Because 2 minus 2 is 0. So what do we need to plug in for x? A 1, right? You could see that with your eyes if you need to. You could do this. You know. Right? Because we divide. You could do that work, but I think in many of our cases, you could just look at what you need to plug in. Now, what would make the bottom of 0? 0, right? So these aren't hard if you set your fraction up correctly. If you leave it like this, the chances are you're going to miss that 0, that 1, that 0 at 1. Okay, what do we do once we find x? We have to set up a sign chart. So we have 0 and 1. Now, are signs going to alternate? Yes, nobody's squared, right? Signs are going to alternate, so we only need to find one. What number you want to plug in? Our two favorites are already gone. Should we plug 2 in? If you plug 2 in here, Are you going to get a positive or a negative? Well, if you plugged a 2 in here, you'd have the cube root of 2 over 2. 2 minus that. What do you have? Positive or a negative? You're going to get a positive, right? And you could plug it into this one. You know the bottom's positive. If I plug a 2 in, the cube root of 2 times 2 is going to be bigger than 2, so it's going to be positive. So if this is positive, what are we doing from 0 to 1? Negative. And what are we doing after 0? Or before 0? Positive. How do we know our signs alternate? Because we don't have a bounce, right? We don't have a squared factor. So what do we call the positive? Increasing, decreasing, increasing. Increasing to decreasing, decreasing to increasing. So this is a max, this is a min. Once we have a sign chart, is everybody okay writing down what we have? So we have a max at x equals 0, a minimum at x equals 1. We are increasing from negative infinity to 0 and 1 to infinity, right? And we are decreasing from 0 to 1. And again, if you kind of want to color code, so your eyes pick up what you're doing, you know I love. I can even highlight that so I know why it's increasing or decreasing, right? How are we? Are we okay? I got to make sure you're okay because now I have to make you work hard. 2 more problems and we'll be done. If you miss class and you're watching this, you can pause it and take a break. All right. Think for a minute. What do I have to do to take the derivative of this critter? What do we need? What's the derivative of that guy? You've got a top and a bottom, and what does this symbol mean? Divide. So what do we have to use in calculus to divide and take a derivative? What do you need, people? The quotient rule. All right, in case you forgot, what's the quotient rule? Bottom times derivative of top minus the top times the derivative of the bottom. Now, since we're subtracting, what do we need to put around this? Brackets all over bottom squared. Tell me something you should be thinking. If you know the bottom squared, what sign will your bottom always have? Positive, right? Think about that. So as you're doing your sign chart in a minute, if we have a top and a bottom, we only have to worry about the top because the bottom's always positive when it's squared, right? Takes a little bit of math away that you have to do. Okay, let's go. All right, people, what is this? Bottom times derivative of the top minus, and I'm going to put a bracket. Anytime we have a minus, we want a bracket so we don't forget a sign. Top times derivative of the bottom. What's the derivative of the bottom? I'm going to write it out front because it's easier for me to do the math that way. All over bottom squared. Okay, not too bad, right? Not too bad. Let's do this. 2x times x squared is 2x cubed minus 18x. Now, this is going to be what? 2x cubed plus 2x. But I'm subtracting, so minus 2x cubed minus 2x. All over. See, I wasn't so mean, even though I'm making you use the quotient rule. So this guy and this guy are going to zero out. And what do we have? Negative 18 minus 2 is negative 20. So what would make the top 0? What would make the top 0? 0. What would make the bottom 0? 9 minus 9, x squared has to be 9, so x has to be what? 3 or negative 3. Now tell me, at negative 3, are we going to have a sign change? What is the factor on the bottom? The whole thing. Squared. So are we going to have a sign change at negative 3 or 3? We are not, because this is squared. It's going to keep its sign. So we only have to figure 1 out. What number would you guys like to plug in? 1? Should we try 1? That's the easiest. So plug 1 in. The bottom's always positive, right? Because it's squared. If you plug a 1 in, negative 20 times 1 would be a negative number. So this is negative. Once you find 1, are we going to have a sign change at 3? No, because the bottom factor is squared. Are we going to have a sign change at 0? Yes, because that came from the top and the top is not squared. So we're going to have a sign change at the 0. Then at negative 3, will we have a sign change? No, because it came from the bottom and the bottom is squared. That's a squared factor. Now, if you're, excuse me, if you're uncomfortable knowing positive or negative, are you allowed to plug a negative 4 in and see? Are you allowed to do that? Yes, you are. And think about it. If you plug a negative number in, a negative times a negative is what? Positive. And if you plug a positive number in, a positive times a negative is negative. So this is positive. That's negative. So what do we have at 0? A max. Do we have a minimum? None. Now increasing. And decreasing. Now this time, can we say it's increasing from negative infinity to 0, or do we need to break it up at the 3? Do we need to do this? We need to do that because we can't include the negative 3 this time. How come? Because it came from the bottom, and you know that if something makes the bottom 0, it's an asymptote. Right? Okay, if you can read that, it says asymptotes. All right, are y'all okay? Any questions? What we're doing today isn't hard. Pulling back in some of your old algebra and calculus is what makes it like, oh. All right, one last problem. Analytically determine intervals for increasing and decreasing in all extrema of the function. Max and mins. Same directions we've had on every problem, right? So what do we do first? Find the derivative. Now, when you have an E, you write down exactly what you see. Then what do you do to take the derivative? You take the derivative of that exponent. What's the derivative of negative x squared? Negative 2x, right? Now we set it equal to 0. And that's times e to the negative x squared. I want you to think about it that way, because when you have two factors multiplied equal to 0, you set each one equal to 0, right? So this is really, though, right? So we're going to say negative 2x equals 0 and e to the x squared equals 0. Well, what would make negative 2x equals 0? 0. What can you plug into x squared when you have e to the x squared to get it equal to 0? Can you? Is there anything you can plug in here to get a 0 out? No, it's something raised to a power, right? E to the 1 is e. E to the 0 is 1. So we can't do that. It's never going to happen, is it? When you have an exponent that's a variable, there's nothing you can plug in there to get to 0, is there? Because nothing raised to a power is 0, is it? And when we raise to the 0 power, we get 1. So that's kind of easy if you know it. Now you know it if you forgot it. So we only have 1. Are the signs going to alternate? Yes, they are. Because the e is not squared. So pick a number to plug in. How about 1? If you plug a 1 in here, you get negative. Tell me about this. Is that always going to be positive 1 over e to the x squared? It's always positive, right? So I only have to look at this. And if I plug a positive number in here, negative times a positive is negative. If I plug a negative number in, like negative 1, a negative times a negative is positive. And if we're positive to negative, what do we get at 0? We get a max. Do we have a minimum? None. And of course, this is increasing and this is decreasing. So it's increasing negative infinity to 0, 0 to infinity. Again, if you like matching stuff up, plus is increasing, you can color code. All right, that wraps up our first day. Let's summarize what we learned. You take the derivative, you find out where the derivative is 0 or undefined, and then you put those zeros or undefined on your sign chart, and you plug a number into the derivative to see if it would be positive or negative. We realize that we can cheat a little bit, and if a factor is squared, we know signs stay the same, and we could get done a little faster. We know if a factor itself isn't squared, they're going to alternate, or fourth power, any even power. Okay, that is it for today.